In this module, we're going to explore network planning. We're going to start off by having a look at the events and activities that influence network planning. Network planning during a migration project is influenced by the current network infrastructure design. The design could also be impacted by compliance and regulatory constraints, as well as scalability and disaster recovery considerations. Performance requirements are usually a key consideration, and these need to be balanced with costs. And most cloud platforms will have a set of networking best practices that need to be complied with. Let's explore some cloud networking design decisions that will have to be made. During network planning, the number of networks needs to be considered. The type of network also needs to be considered. For example, should a custom network be created or is the default network sufficient? And there are numerous options for configuring firewall rules, and all of these need to be taken into account. And there are different types of IP addresses that can be allocated. For example, static or ephemeral IP addresses, public or private IP addresses. From a hybrid connectivity perspective, there are a number of options that we may consider. One of those options is a virtual private network, or a VPN. A VPN allows us to have an encrypted connection between two networks over the public internet. This enables organizations to securely migrate workloads from networks that originate from outside of the cloud environment. An organization may also choose to invest in a physical connection between an on-premises network and a network in the cloud. Another hybrid connectivity option that is popular with large enterprise organizations is network peering. Network peering allows organizations to peer an existing on-premises network with a cloud network at an edge peering location. This enables the organization to securely access cloud services. There are a range of network services in the cloud that need to be taken into account during a migration project. Services may include NAT gateways that enables virtual machines without a public IP address to be able to access resources on the public internet. Other services include routers that enables packets to be able to get to the relevant destination, as well as DNS that enables the discovery of services using domain names, and load balancers that enables traffic to be routed to a backend of choice. These are just a subset of the range of network services that are available in the cloud. And in the last topic of this module, we're going to take a look at data transfer. Let's have a look at this from the perspective of inbound or ingress traffic. From an inbound traffic perspective, load balancers play a key role in enabling inbound traffic to be routed to cloud resources. Content delivery networks can be used not only to reduce cost, but also improve performance by caching content at the edge of the network, thereby reducing latency. And for enhanced security, customers can configure web application firewalls in order to keep malicious traffic out of the network. Now we're going to take a look at systems that play a key role in outbound or egress traffic. In the cloud environment, a significant amount of egress traffic originates from virtual machines. As a storage system of choice for binary large objects, object storage also generates a significant amount of outbound traffic. And depending on the type of application, there may be a consideration for traffic between the application tier and the transactional tier, which may be implemented as a relational database. And unlike ingress or inbound traffic, egress or outbound traffic is usually billable. Therefore, the connectivity options need to be taken into account. VPNs are usually cheaper than layer 2 connections at the physical level. However, layer 2 connections at the physical level usually provide better performance as well as more capacity. And during network planning, it's very important to carefully consider the cost and performance implications of routing traffic across geographical regions and across failure domains within a single region. This concludes our discussion on network planning. During the network planning phase, it is important to carefully consider the cost and performance implications of the different network configurations and services available in the cloud.